Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
All right, in this video, we want to jump in and start the modeling phase of this project. And so the first classification model we'll use is logistic regression. And in this video, we just want to discuss what is a logistic regression. Now, some of you might be familiar with it, I understand that, but just want to give you a quick recap, and let's recreate our fake data that we did earlier in the course, all right? And so we have, we have this height, weight, and gender data frame that we created. So let's just create a vector called height, and so we'll just kind of get 25 observations. We'll start at 36 and go to 84. So we'll just do this as inches. And so we'll create height, and then we'll create weight. Again, create some random data here. And we'll say 25 observations where we start at 90 and go to 250. Okay. And then let's create our gender. And we'll say, I'm going to actually do this a little bit different. Instead of male, female, I'm going to sample from 0 and 1. And so replace is going to have to be true, and our probs will be 0.5, 0.5. Okay. And let's just say that 1 is female. Okay, we'll say 1 corresponds to being a female. And so we'll create something called mod data, where we have a data frame that is height, weight, and gender, just like we did before. All right, so I want to check the structure of this. Okay, all those are numeric. So what we'll need to do is, in order to do this, we need gender to be a factor variable. So we'll just create turn it into a factor variable here. All right, let's just check the structure, make sure we're good there. So you see we have height and weight as numeric inputs, and then gender will be factor. And so factor will be the target variable here. See, it has 2 levels, 0 and 1, corresponding to 1, 2, 1, 2, 1, 2. Okay? And so 2 would be female, so 1 would be female, right? And so then what we want to do is create a regression model. And just show you how to do this syntax. GLM is the function, so it's a general linear model. And so it's going to be gender onto everything. So height and weight, data is mod data. And then we have family is equal to binomial. And so that tells R that, hey, we are modeling, we're using a general linear model to model a binomial or a dichotomous target variable, okay? And so we'll go ahead and create that model there. And then we can say summary log reg mod. And so we'll print the model output here that we want to see, okay? And so what we get is similar model output to what we saw whenever we ran linear regression in the last section, whenever we did our regression models, right? And so we get a statement of the formula, we get some residual distributions. What we're really interested in here is our parameter estimates, right? The coefficients of our model. And so we get an intercept term of 4.65, we get a height term, a height coefficient negative 0.1, and a weight coefficient of 0.00. So first of all, right off the bat, it's really not surprising that height and weight have estimates that are really close to 0, right? This is just random data. We wouldn't expect to see any sort of relationship. Honestly, the fact that height comes with a 1-star rating, meaning it's significant, under the 0.05 level, is pretty surprising. If we ran this again, if we ran our random data again, we probably would not get that. It's a bit of a random fluke here. We wouldn't really expect to have much of a relationship with that random data. And so again, that's why the estimates for those two are 0. It just means they're not going to change much. Or as you change the values of height and weight, we wouldn't expect it to do a whole lot on whether or not the individual is or the record has a 0 or a 1 attached to it. And so with logistic regression, what's interesting about logistic regression is that we change the way we interpret this output, right? And so what we have, logistic regression models, okay, logistic regression models the log odds of the outcome, okay, the log odds of the outcome. So you might recall from a stats class, if you've ever had one, that odds equals the probability of occurrence, do it this way, divided by the probability of non-occurrence, right? Non-occurrence. So we have the probability that something's going to happen divided by the probability that the thing won't happen. That's the odds, right? And so the log odds, or log of odds, is equal to the log of the probability of occurrence divided by the probability of non-occurrence. Okay, and so whenever we think about our outcome, what logistic regression is really doing is treating log odds as the outcome variable. Okay, it's treating log odds as the outcome variable. And so whenever we see these parameter estimates of a negative 0.1, it means that for a unit increase in height, if height goes up by 1, the log odds of the individual, in this case being a female, goes down by 0.1. And so for every unit of height that increases, the log odds that the individual is female goes down by 1. And similarly for height, for weight, for every unit of weight increase, the log odds that the individual is a female increases by 0.007. So again, not very much, but that's the way we think about those estimates, right? And so we're still thinking in terms of, a negative means the outcome goes down. Positive parameter estimate means that variable makes the outcome go up, just like in linear regression. The difference is, what is that target variable? It's not directly male or female. It's the log of the odds that individual is male or female. In this case, we're using male as the index starting point, and so the change in log odds happens relative to being a female, right? So the change is, do the log of the odds go up or down? And so we can actually to see the odds directly, simply exponentiate the coefficients, right? So just exponentiate the coefficients. So we'll exponentiate exponentiate, I think if we say coef logarithm mod, that should give us our coefficients. There we go. Okay, so typically, don't worry, don't try to interpret the odds for the intercept model, for the intercept term, right? However, for the two input variables, we can kind of interpret these. And so basically the odds on each of these are 1 to 1. So essentially, our odds here are 0.9 and some change, 1 and some change, right? And so what we see is that for both height and weight, the odds, the odds ratios here, in other words, the odds ratios are really close to 1, which basically tells us that it's kind of a coin toss, essentially, about what would happen in terms of male or female based on height and weight. So again, for this fake data, we kind of understand that that's sort of the case. All right. So that's really all there is to logistic regression. We need a factor variable for our target, and then the GLM function will convert that response into log odds and model log odds as the response variable. And then we really interpret the coefficients very similarly. We're just saying, is our likelihood of getting the likelihood of the outcome changing, is that going up or down?
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.